Question 5 is from 4 chapter 3. Ajar 5.1 menunjukkan formula struktur bagi kafein yang boleh dijadikan sebagai baja semula jadi untuk tumbuhan. Nyatakan formula molekul kafein. Okay, in this case, very simple. You just count how many carbon you have, how many atom carbon you have. Count how many atom hydrogen you have. Alright, carbon. Count how many atom oxygen you have, as well as nitrogen. Combine that all, you'll get this formula. Very simple. You just have to count how many carbon, hydrogen, oxygen and nitrogen there are. Okay. Kira peratus nitrogen mengikut GSIM dalam kafein. So you can get the total GSIM, correct? Because they already give GSIM atom relative for each one element. So what you do now, to get your peratus, you must basically know your jumlah GSIM only for nitrogen divided by jumlah GSIM for caffeine. With this, you times 100%, you will get peratus nitrogen. Okay, there we go. Okay, alright, easy 2 marks there. Alright, so there shouldn't be any doubts here lah. It's a very straightforward question, as well as the working is also very easy. Okay, next. Baja biasanya mempunyai kandungan nitrogen yang tinggi. Okay, nitrogen diperlukan untuk meningkatkan pembesaran. Basically, untuk meningkatkan pembesaran tumbuhan. So nitrogen is good lah. The more nitrogen, the higher the rate of growth for that plant. Antara contoh baja yang digunakan oleh petani ialah urea. Berdasarkan peratus nitrogen mengikut GSIM dalam kafein dan urea, tentukan baja yang terbaik yang patut digunakan oleh petani untuk tanamannya. Jelaskan. Now, based on this statement, you know the more nitrogen it has, the higher the peratus nitrogen, the better it will be for the plant, correct? So in that case, you already find peratus nitrogen for caffeine here. Do the same thing for urea. Find the peratus nitrogen for urea and then you compare. See which one has higher peratus nitrogen. That will be your best baja. Why? Again, you come back to the statement because they say nitrogen is good for tumbesaran. The higher the nitrogen, the better it is. So based on, the calculation, you see peratus nitrogen in urea is 46.67. Higher than caffeine, right? Okay. So peratus nitrogen dalam urea lebih tinggi. Yes. Okay, 1 mark here and 1 mark here. Done. 2 marks. Very simple. Okay. Next. Oh, we have continuation. Okay. For question 5. Okay. Pelajar 5.2 menunjukkan susunan radas untuk penguraian serbuk kuprem 2 karbonat. Okay. Serbuk kuprem 2 karbonat. Apakah fungsi kapo? So kapo is basically used to identify the presence of carbon dioxide gas, untuk mengesan kehadiran gas carbon dioxide. Okay, next. Tuliskan persamaan kimia yang seimbang bagi penguraian serbuk kuprem 2 karbonat. So, CO3. Okay. Number 1, you hasilkan CO2. Correct? And apart from that, you see this bubbles itself shows that there are CO2 in it lah. Okay. Next is cuprum oxide. It will form cuprum oxide. Okay. Yes. So this is the formula. The persamaan kimia. Okay. Then very simple. Okay, next question. Question 6. Raja 6 menunjukkan tindak balas menggunakan dua jenis garam. Dua jenis garam terlarutkan untuk menghasilkan sejenis garam tak terlarutkan. Nyatakan nama tindak balas bagi menyediakan garam tak terlarutkan itu. So, penguraian ganda 2 lah tindak balas penguraian ganda 2. Okay. Before I continue, okay. Garam is a very important topic, especially, overall, it is a very much important topic, and it is quite, a challenging topic as well, challenging subtopic. So in that case, I advise you to go watch my video on garam, and then come back to this question, because if you don't understand garam, let's say you just ala kadar je, you don't just touch the surface of garam, it's going to be very difficult for you. Alright? So yeah. Now wait, let me just explain 4 jenis garam. So you have garam jenis nitrat, garam jenis karbonat, garam jenis klorida, and garam jenis sulfat. So for nitrat, all type of garam nitrat is soluble in water. It will larut dalam air. For ion chlorida, semua jenis ion chlorida, correct lah. So for garam jenis this chlorida, semua larut kecuali termonomic, kecuali plumbum, argentum and mercury. Kecuali plumbum chlorida, argentum chlorida, mercury chlorida tidak akan larut dalam air. As for your sulfat, PCB, plumbum sulfat tak larut dalam air, calcium sulfat tak larut dalam air, as well as barium sulfat. For your carbonate, it's the opposite. Semua tak larut kecuali this. Ammonium, nitrium, which is sodium, as well as kalium. Right? Simple as that. Okay. So when argentum nitrat bertindak balas with natrium carbonate, okay, argentum is positively charged, nitrat negative, positive negative. So there will be bond between these two, electrostatic bond between this positive and negative, positive and negative. So here it will form argentum carbonate. Your pepejal acts as argentum carbonate, whereas your larutan here is natrium nitrat. As I said, semua jenis garam nitrat larut dalam air. Semua jenis garam karbonat tidak larut dalam air kecuali ammonium, nitrium, kalium. Okay, tu. Next question. Kenal pasti pepejal X. Simple. Argentum chlorida. 1 mark. Tulis persamaan. Next question. Tulis persamaan kimia bagi tindak balas antara argentum dan natrium karbonat. Okay. Argentum plus natrium carbonate will form argentum carbonate plus natrium nitrat. Okay, it's not balanced. Here natrium, there's 2. Here to make it 2, add 2 in front here. Okay, wait, okay. And then argentum, here also there's 2, but here there's only 1. So add 2 in front here. I think the rest should be it. Okay. There you go. Easy 2 marks. Make sure you balance the chemical equation. Okay. Next, hitungkan bilangan ion argentum dalam 20 cm cube larutan argentum nitrat they gave the volume as well as the 0.5 is the kepekatan. Okay, so based on this, you can identify this formula to get your bilangan mol. Next, dan seterusnya tentukan jisim pepejal X. Pepejal X is argentum. So now N equals to kepekatan dalam volume divide 1000. So you get your bilangan mol for ion argentum. Okay. So since they are asking for pepejal X, you do the the ratio system lah. Where they are asking for pepejal X, which is this. And you already have ion argentum dalam larutan argentum. You have this. So based on your equation here, you can see 2 to 1, correct? That means 2 argentum nitrate can produce 1 argentum carbonate. So you use nisbah, use ratio and get your bilangan mole for argentum carbonate, which is 0.005. Then to get your GC, obviously GC is equals to bilangan mole times GC molar. Do that and you'll get your GC. 2 marks. Here 1 and here 1 for your ratio 1. So 2 marks lah. Okay, uraikan secara ringkas bagaimana untuk menyediakan hablo garam daripada pepejal X. No matter how you create that garam, at the end of that experiment, you must ensure these 3 things. Number 1, the garam that you made must be a solid. Number 2, the garam that you made must be clean. Clean, how can you clean the garam? Is by using air suling. Number 3, the garam that you made must be dried. How? Using kertas turas. So remember how in garam there's a few methods. Dalam penyediaan garam there's a few methods to create garam, right? Which is, for instance, like this, penguraian ganda 2, and then we also have penyediaan garam terlarutkan bukan jenis amonia, nitrium dan helium. So with all this, right, with all these methods, at the end of the day, the garam that you make must be a solid, must be clean and must be dried. To make it clean, you use air suling. To make it dried, you use kertas turas. To make to get that solid, you can turaskan with kertas turas as well. Okay, so in this case, you already have your pepejal here, right? But however, though, it is still together with the larutan natrium nitrate. So first thing what you should do is you turaskan your pepejal X dengan kertas turas. So you'll get a perfect solid already. Check. Done. Next, bilas pepejal dengan air suling Y to ensure that it's clean. Check. Right, next, keringkan pepejal X dengan meletakkan pepejal X di antara 2 helaian kertas turas. So it will look somewhat like this. Kertas turas and then your garam. What you do, you just like tap on this kertas turas. You tap on it and it will make your garam dried. Done. 3 criteria, all 3 criteria are fulfilled. Alright, so you will get 3 marks if all 3 criteria are fulfilled. Okay. Next, question 7. Raja 7 menunjukkan sebuah sampan kayu dan kayak. Kedua-duanya diperbuat menggunakan bahan komposit. So this is form 4, chapter 8. Bahan komposit terdiri daripada gabungan bahan matriks dan bahan pengukuhan. Apakah fungsi bahan matriks? So bahan matriks digunakan untuk melindungi dan juga mengikat bahan pengukuhan bersama. Right? It's similar to the definition question you must refer back to your textbook. Alright? Okay. Nyatakan bahan komposit yang sesuai untuk pembuatan kayak. Bahan komposit. Okay. Why kaca gentian? So, kaca gentian, hold on a second. Okay. Kaca gentian, it basically tahan lasak. Tahan lasak. It can tahan, kakisan. That means it won't get, dia tidak akan berkarat very fast. Penebat haba and kekuatan legangan tinggi. So the best is kaca gentian. Okay. One mark there. Okay. Okay. Oopsie, sorry about that. Okay. Radas kaca makmal seperti bika dan kelalang diperbuat daripada kaca borosilikat kerana sifat rintangannya terhadap haba. Satu sampel kaca borosilikat mempunyai komposisi silika 18%, boron oksida 15% dan juga aluminium oksida 5%. Hitung jisim setiap komponen dalam sampel kaca borosilikat dengan jisim 1 kg. So this 1 kg, to make things easier, I change it into gram. But if you want to remain it as 1 kg, also can, no issues. So it is super simple. They gave you the jumlah jisim, they give you the peratus. So the peratus, you just times with the jisim given, and you can get the jisim for each component. Okay. So jisim silika would be 800 gram, jisim boron oxida 150 gram, jisim aluminium oxida would be 50 gram. Easy 3 marks there. Okay, next. Berikut adalah perbualan 2 orang pelajar tingkatan 5 sains tulen. Okey. Adam, makanan yang panas tidak sesuai dihidang dalam bekas kaca plumbum. Ya betul, Cikgu Siti pernah beritahu kita dalam tajuk komposisi kaca. Tetapi saya terlupa mengapa ianya tidak sesuai. Now, plumbum basically what happens is that it can easily melt. It can easily melt. When you heat it up, it can easily melt. So if let's say you put makanan panas, due to the heat transfer, plumbum will melt and mix together with the food. So if plumbum mix together with the food, you would get berisiko keracunan plumbum. Okay. So first, plumbum mudah luntur. Plumbum boleh melarut ke dalam makanan and it can cause keracunan plumbum. 3 marks there. Alright. Okay, right. The next one. Cermin mata Ellie diperbuat daripada jenis kaca plumbum. Ellie dapati ianya bersilau terutama ketika berada di bawah sinaran matahari. Ellie ingin menukar kepada kancah cermin jenis lain. Pada penilaian anda, apakah jenis cermin yang perlu Ellie pilih bagi mengatasi masalah yang dihadapi? Cadangkan kelebihan daripada cermin kaca yang dipilih. Okay, so kaca fotokromik lah, correct. Okay, why? Because kaca fotokromik tidak menyerap sinaran UV, so she won't have all those issues lah. Okay, now as I don't think I mentioned this earlier, but I'll mention it now. So Form 4 Chapter 8, to be honest, it requires several things for you to memorize. You have to hafal. Okay, not everything, but like all the small, the function, the composition, what is it used for, all this you have to memorize, unless if you do a lot of questions until you teringat. Okay, you terhafal, then that's a different story. But if let's say you don't do that much of questions, then you have no choice but to hafal lah, right? Okay, So yeah, we are done with question. So yeah, we are done with question 7.